Hello everyone. In this session, I will share with you the property of Z transform. Property of Z transform include the linearity, time reversal, time shifting, convolution, correlation, scaling, differentiation, time integration, initial value theorems, and final value theorems. We shall look at it one by one. First of all, let's look at the linearity theorems. If Z transform of the x1n is x1z, and if Z transform of the x2n is x2z, then xn will be the a1 x1n plus a2 x2n, or this also will equivalent to the a1 x1z plus a2 x2z. And in this case, a1 and a2 is the constant. So this implies that the Z transform for a linear combination of signals is the same linear combination of their Z transform. Now let's look at the example. Determine the Z transform of the signal xn equal to delta n plus 1 plus 3 delta n plus 6 delta n minus 1 minus delta n minus 4. Find the corresponding discrete signals and the region of convergence. So by using linearity property, Z transform can be do it like this. Okay, xz equal to Z transform of delta n plus 1 plus 3 Z transform of the delta n plus 6 Z transform of the delta n minus 3. 6 you can take it out because it's a constant. Okay, minus with Z transform of delta n minus 4. So from here we know that this is the location. This is a location. Okay, like this is the origin. This one is the n equal to minus 1. So you have the Z plus 3. Okay, this is at the origin. Plus 6 Z minus power minus 3. This is the location at power n equal to 3. And this is n equal to 4. Okay, minus Z power of minus 4. So this is the Z transform. And then you can find the discrete signal. So based on here, you can find the discrete signal. So also from here also can get a discrete signal. So that is, you know that left hand side we have n plus 1. So it's a minus 1. You have the value of 1. And then you have the origin 3. And then you have the 6 at n equal to 3. So 1, 2, 3. 1 and 2 don't have the value, so we top up with the 0. And then n equal to 4, you have the value of minus 1. Next is to find the ROC. ROC you can refer to the table. So this is the two-sided. Left hand side you have value, right hand side also have value. So we can check the table for the ROC. For the ROC, for a finite sequence, okay, two-sided, that is the ROC is the entire Z plane except Z equal to 0 and Z equal to infinity. Next is the time reversal, means that is a folded version. This means that xn we change to x minus n, it's a folded version for the time reversal. And then from x minus n, you change to Z transform. Okay, we change to Z transform, you get x Z power of minus 1. And then for the ROC is from the 1 over R2 smaller than the modulus Z, smaller than the 1 over R1. Now, let's look at the example. Find the Z transform of the signal xn equal to u minus n and the region of convergence. In this question, we can say that if xn equal to un first, we assume first the xn equal to un. This means the xz, the Z transform of the xn, will be using the formula is 0 to infinity xn Z power of minus n. Okay, we substitute in the value. So there will be 0 to infinity. Okay, you know the un is from 0 to infinity. Okay, so this will equal to 1, okay, minus n. Okay, you substitute the value. So this is the formula. This is the formula. And then I substitute in the xn equal to un, and then this is the limits, and then the un, the value of un, since you already substitute the limits here, then the amplitude is 1. Okay, now you have a z power of minus n. So summation n 0 to infinity, z power of minus 1, I factor out, I get z power of minus 1, power of minus n. So if I compare with the sequence, okay, sequence and series and sequence, so I can get alpha. Okay, if I compare, I will get this one, alpha n equal to 1 minus alpha. This is the sequence. So I assume here from the comparison, alpha is equal to z power of minus 1. So I substitute in the formula 1 minus alpha, so 1 minus z power of minus 1. So if I change it to another form, I can get z over z minus 1. Okay, so this value is for xz. Okay, if okay, x z minus 1. So this will equal to what? This means the z will change to the z minus 1. So I get z minus 1 minus 1. This means z power of minus 1 is 1 over z. This means 1 over z. So I check it 1 over z. Then what do I get? I will get 1 over 1 minus z. Okay. From here, we can say that 1 minus z more than 0. Okay. So minus z more than minus 1. So z is less than 1. Okay. Z is less than 1 when we draw a circle of 1. So this means that the ROC is the anticlosal. Anticlosal, okay, because due to the u minus n. So it is anticlosal. When it is anticlosal, we can check this infinite sequence because u minus n is left-sided, so it's anticlosal, and the ROC is inside the circle. So therefore, the ROC is inside the circle. The z less than 1. Next property is the time shifting. If the z transform of the xn is the xz, then the xn minus k is z power of minus k xz. So the ROC of the z minus k xz is the same as that of xz, except for z equals 0 if k more than 0, and for k equal to infinity if k less than 0. This means that the shifting does not change the ROC, and it has the same ROC. Now let's look at the example. Calculate the z transform of the xn equal to u n minus 2. In the previous example, we know that the xn equal to un. Okay, if the xn equal to un, and then we get the xz equal to 1 over 1 minus z minus 1, or we can get z over z minus 1. So in this question, that is if xn equal to u n minus 2, this means that the xz is equal to z power of minus 2 xz. Okay, do you know how to get this? Okay, this is based on the time shifting property. Okay, time shifting property say that x n minus k is z power of minus k xz. This is the property of the time shifting. So since the question is u n minus 2, this means you will get the n minus k, right? N minus 2, okay, you compare with this, so n minus k. So you will get z minus k. So your question is minus 2, so you will get z minus 2 x z. Okay, then z minus 2. Okay, since we have this answer or this answer occur, okay, so we can use the first one, z power of minus 2. We multiply with the xz. Okay, if the xz is 1 over 1 minus z power of minus 1. So this will equivalent to z power of minus 2 divided by 1 minus z minus 1. Okay, then what if we use z over z minus 1? Also, we can get the same answer. Okay, or okay, xz equal to z power of minus 2 xz. This is equivalent to z power of minus 2 z over z minus 1. Okay, this means the z divided by z squared divided by z minus 1. Okay, so you will get 1 minus z divided by z minus 1. Okay, because this one you cancel out, we get 1 over z. So what if we want to get this form, okay, this form, how to do is we can everything divide by z. So you will get 1 over z square divided by z divided by z, you get 1 minus 1 over z. Okay, so this will equivalent to z power of minus 2 divided by 1 minus z power of minus 1, which is the same as the another answer. Okay, so this is about the time shifting. Next is the time scaling. Scaling said that if z transform of the a n x n, you will get x a z minus power of minus 1. And the ROC is modulus a r1 less than modulus z less than modulus a r2. Okay, now let's look at the example. This question consists of the scaling property and the shifting property. First of all, we can do the shifting first, then scaling. We know that the z transform of the un is equal to 1 over 1 minus z power of minus 1, or we can say that z over z minus 1. Okay, this is different if you use this equation or this equation. First of all, we use 1 over 1 minus z power of minus 1. Okay, so in this case, z power of minus 1 will be substituted with a z power of minus 1. If you still remember, the scaling property said that a power of n x n, we will get x a minus 1, a power of minus 1 z. First of all, we do the shifting first. Okay, to do the shifting, so z transform of unit step n minus 2, you will get z power of minus 2 divided by 1 minus z power of minus 1. And then next is the scaling. Okay, for scaling, z transform of 2 power of n u n minus 2, this is equivalent to z power of minus 2 divided by 1 minus z power of minus 1. So this is we copy from the top. And with the condition, z power of minus 1 will be substituted with the value of 2z power of minus 1. This is because from the question, okay, from the question is 2 power of n u unit step n minus 2. So from the properties, we say that a power of n x n is x a power of minus 1 z. Okay, this means the z here, z power of minus 1 here will be substituted with a z power of minus 1. So therefore, here I substitute with the z power of minus 1 will substitute with the 2z power of minus 1. And here we get z power of minus 1 power of 2 divided by 1 minus z minus 1 of 2. Okay, and then you are equivalent to 4z power of minus 2 divided by 1 minus 2z power of minus 1. Okay, that is, we use this answer if we assume the un, if we assume the z transform of the un is 1 over z minus z power of minus 1, and then you will get the answer. We will substitute the z power of minus 1 with a z power of minus 1. What if we use z over z minus 1? The answer, the substitution will be different. If we use this one, okay, we will substitute it with z equal to z over a. Okay, z over a. That is a z a power of minus 1. It's slightly different. So I write down here for the 2 power of n u n minus 2. Okay, for the shifting part, I have unit step n minus 2 equal to z over z minus 1, and then I multiply with z power of minus 2. This one is for the shifting, okay? So from here I get 1 over z minus 1, because I cancel out the z here, because z multiplied with 1 over z power of 2, so you can cancel out. I get and remain 1 over z, okay, multiply with z minus 1. So next is the scaling. For the scaling part, a power of n xn, okay, I change to x a minus 1, a power minus 1 z. So 2 power of n, then I will get 1 over 2 z. Okay, so xn equal to 2 power of n u n minus 2. So from here I get 1 over z minus 1. Then z is substituted with the z over 2. So this will equivalent to 1 over z over 2 multiplied with z over 2 minus 1. So we substitute all the z with the z over 2. So this will equivalent to 1 over z squared divided by 4 minus z over 2. Equivalent to, okay, this one I time with 2. This one also time with 2. So now I can get 4. Okay, I bring up the 4 to the numerator. 4 divided by z squared minus 2z. Okay, and I get, okay, and I divide, okay, I divide with the z squared, so I get 4 divided by z squared, and then z squared divided by z squared minus 2z divided by z squared. I get 4z power minus 2 divided by 1 minus 2z power minus 1. And this answer same as the one I used, 1 over 1 minus z power minus 1. Now let's look at another example. By applying the time z transform property, determine the inverse z transform of the signal xz equal to z power minus 1 divided by 1 minus 3 z power minus 1. Okay, in this question we can solve like this. We can take out the z power of minus 1. So we get xz equal to z power of minus 1. And then 1 divided by 1 minus 3 z power of minus 1. Okay, we take out the z power of minus 1. So this one is equivalent to z power of minus 1 and x1z. So now our x1z is referred to 1 over 1 minus 3 z power of minus 1. Okay, now we want to write the xn, the inverse, right? We want to find the xn. Xn equal to, okay, we follow the shifting. We can get xn minus k, which is equivalent to z power of minus k xz. So now we have here z power of minus k x1z. in which we can get x n minus k, right? So now we have u n minus k. Now minus k, in this case we have minus 1, so it's n minus 1, u n minus 1. It's a unit step, u n minus 1. And then for this part, okay, this part we already get it from here. And then for this part, we can get 3 power of power n. This is from the scaling property, in which a power of n xn, you will get x a power minus 1 z. So now we have a power of n, this one, a power of n. And then for the n, we should follow n minus 1. Okay, we should follow n minus 1. So your answer is xn equal to 3 power of n minus 1 u n minus 1. Here I would like to summarize the Z transform from the Z transform xz to xn. We can do the scaling first, then shifting. Okay, so let's say we have a question like z power of minus 1 divided by 1 minus 3 z power of minus 1. And then we compare with 1 over 1 minus z power of minus 1. So we can see that this is the shifting. And whereas this part is the scaling. So how to do from the Z transform to the xn? So for the scaling first, so we can have a 3 power of n un. Okay, this is the scaling. Then shifting. Okay, so this is scaling. Then shifting. So for the shifting is 3 z power of minus 1. So it's 3 n minus 1 u n minus 1. Okay, this part we can get it here and also here. So make sure these two are the same value. So it's n minus 1. Now if you have the xn and we want to get the Z transform, okay, we can do the shifting first, then scaling. So now let's say we have 2 power of n u n minus 2. If we shift first, we can get z power of minus 2. So this part we can get it from here. So 1 minus z power of minus 1. Then scaling. So z power of minus 2 divided by 1 minus z power of minus 1. Then the z power of minus 1 will be substituted with 2z power of minus 1. And 2 times z power of minus 1. This is because we have 2 here. Okay. So we substitute in. So 2z power of minus 1 square divided by 1 minus 2z power of minus 1. Then we get 4z power of minus 2 divided by 1 minus 2z power of minus 1. That's all. Then we can move to the differentiation property. If differentiation property is, if Z transform of the xn is xz, then n xn is z minus z differentiate the xz over dz. Now let's look at the example. Find the Z transform of the xn equal to the n square un by applying the differentiation property. Okay, if question is xn equal to n square un, then Z transform of the n square un is referred to Z transform of n and multiply with n un. Okay, this is equivalent to Z transform of the n xn. And noted that the n xn equal to nun. This is equivalent to z power of z divided by z minus 1 power of 2. By using the differentiation property, the z transform of the xn is z inverse d over d z inverse x z. Okay, so z inverse d over d z inverse. So xz is referred to here. Okay, the xz. So the xz we can say that is z over z minus 1 square. Oops, I missed out the xz here. Okay, so nun, the xn of the nun, xn is nun, then xz is z over z minus 1 square. So I substitute the xz here with z over z minus 1 square. So you differentiate. I can rewrite for the equation. I obtain z inverse divided by 1 minus z inverse square. I assume the numerator is u and assume the denominator is v. Okay. So I use the formula vu prime minus uv prime divided by v squared. So I remain this one. I get z power of z inverse, and then differentiate. Okay, I differentiate. I use this formula. So uv prime and vu prime. So v u prime I get 1 minus uv prime divided by v square. So 1 minus z inverse square and square. So from here I can get 1 minus z inverse. Okay, I split into 2 because of power of 2, right? I split into 2. 1 minus z inverse plus 2 z inverse 1. So this one minus and minus will get plus, so plus 2 z inverse 1 minus z inverse. Then divide by 1 minus z inverse power of 4. So this one and this one can cancel out and I left 3. So z inverse 1 minus z inverse plus 2z minus 1 minus z inverse power of 3. And I left z inverse 1 plus z inverse 1 minus z inverse power of 3. Okay, so this is the answer. Next is the property of a convolution. Convolution can be expressed that x1n convolute with the x2n equal to the summation of x1n minus k multiplied with the x2k. Now let's look at the example. Find the Z transform of the convolution xn of the signal. x1n equal to 4 minus 2, 1, and x2n is 1 from 0 to 3. To do this, first of all, we change the x1n, okay, 4 minus 2, 1 at the origin of 4. We change to the x1z. Okay, so 4 negative 2 z power minus 1 plus z power minus 2. And then x2n, we change to x2z. Okay, x2z. So we have 1, this one. And then for the convolution process is x1 convoluted with the x2, which is equivalent to, in the Z transform, is x1z multiplied with the x2z. So it's easy if we can x1z multiply with the x2z. Okay, so x1z is this one, whereas x2z is this one. So this 4 will multiply with or product with each single value of the z here. And similarly, this one will multiply with another up to the n. So this when you sum up everything, so you get this one. Okay, so this is the xn value from the xz. In terms of correlation, Rx1, x2 equal to the summation of x1, x2, n minus L, which is for the Z transform is Rx1, x2z equal to x1z, x2z inverse. I give you an example here. Determine the correlation sequence Rx1, x2 of the sequence given below by using the correlation property of Z transform, where x1n is like this and x2n is like this. So for the solution, x1n, you can get the x1z. So we look at this x1n. So we can get 1 plus 2z power of minus 1 plus z 3z power of negative 2 plus 4z of power of negative 3. Then y2n, we can get y2z. So here we can get 4 plus 3z power of minus 1 plus 2z power of minus 2 plus z power of minus 3. Then for the z inverse, x2 z inverse, what we can get if we have a x2 z inverse, here we can get 4 plus 3z plus 2z squared plus z power of 3. Okay, and the correlation property said that the R x1, x2, z equivalent to x1, z, x2, z inverse. So this is equivalent to this one and this one. 1 plus 2z inverse plus 3z power minus 2 plus 4z power minus 3. Multiply with 4 plus 3z plus 2z squared plus z power of 3. So this is equivalent. So we are multiplying in everything. So 4 plus 3z plus 2z squared plus z power of 3 plus 8z inverse plus 6 plus 4z power of 1. Okay, so this one, then we continue with this one. So continue everything. And then plus with 2z squared plus 12z power of negative 2 plus 9z power of minus 1 plus 6 plus 3z power of 1 plus 16z power of minus 3 plus 12z minus 2 plus 8z power of minus 1 plus 4. And this equal to z power of 3 plus 4z squared plus 10z plus 20 plus 25z power of minus 1 plus 24z power of minus 2 plus 16z power of minus 3. So from here, Rx1, x2, L should refer to the Z inverse Rx1, x2, Z. So this is equivalent to Z power of 3 plus 4z squared plus 10z plus 20 plus 25z minus 1 plus 24z negative 2 plus 16z power minus 3. So this means we have z inverse power of negative 3 plus 4 z inverse negative 2 plus 10 z inverse power negative 1 power plus 20 z inverse power 0 plus 25 z inverse positive 1 plus 24 z inverse power of 2 plus 16 z inverse power of 3. So this means from here we can convert into a sequence. So we have 1, 4, 10, 20, 25, 24 and 16, where the origin is at 20. Next is about the initial and final value theorems. If xn is a causal sequence with the Z transform of the xz, the initial value can be determined by using the expression x0 limits the n from 0, xn then also equivalent to limits z equal to infinity xz. So this means that if the xz equal to x0 plus with x1 z inverse plus with the x2 z power minus 2 and so on. So if we assume the z equal to infinity and each of the term in the xz goes to 0 except the first one. And then for the final value terms, if the xz equal to z of the xn, okay, xz is the z transform of the xn and the pole of the xz are all inside the unit circles, then the final value of the sequence x infinity can be determined by using the expression of this one. Okay, limits n into infinity xn and limits z modulus z equal to 1, then you have the 1 minus z inverse xz. So if xz equal to 2 plus 3 z inverse plus 4 z power negative 2, find the initial and final value of the corresponding sequence of xn. So for this question, initial values x0 is equal to the limits, the z goes to infinity xz, and here we can get the limits goes to infinity, then 2 plus 3 z inverse plus 4 z power of negative 2. So here we can get, if we substitute the z to infinity, okay, so you have 3 infinity plus 4 infinity, so they will equivalent to 2. So this is the initial value. Whereas for the final value, we have the x infinity equal the limits z modulus z goes to 1. So we have 1 minus z inverse xz. So here we can get the limits z goes to 1. So we have 1 minus z inverse 2 plus 3 z power minus 1 plus 4 z power minus 2. So this will equivalent to 2 plus 3z minus 1 plus 4z power minus 2 minus 2z power minus 1 minus 3z power minus 2 minus 4z power minus 3. So this will equivalent to 2 plus 3z minus 1 plus z power minus 2 minus 4z power minus 3. And this is equivalent when we substitute the modulus z equal to 1, so we have 2 plus 1 power minus 1 plus 1 power minus 2 minus 4, 1 minus 3. This is equivalent to 2 plus 1 plus 1 minus 4, and this is equal to 0. So the final value is 0. And the last property is the time delay for one-sided Z transform. If the Z transform of the xn is xz, then the xn minus k, you will get this one. Okay, so that's all for the property of the Z transform. Hope you can understand. If you have any question, you can text me. So that's all for today. Thank you, class.